Yep. So I got to stay home this week, and it's postponed until that number comes in, and then I'll be traveling. So
Okay.
in some ways that's a good thing. In some ways that's a good thing. In other ways it's not.
Certainly. Okay. So are you ready to start with the material then?
Sure.
I think so.
Okay, so for this week, we had the sampling distributions of the sample mean and the central limit theorem.
Right?
Yes, I am getting there with the definitions.
Yeah, I'm trying to get back to.
Yeah, some things are new, some things are kind of just going over those things from previous courses. I think it's going fine. Okay, so we have part 2. We have a chart where we needed to choose 5 different salaries.
Yeah. I actually printed it out and cut them out.
Okay. So then in here it says, for part 2, it says number 7, randomly select 5 of the 30 salaries and compute the mean. So do you want to do one for our group, or do you want to discuss the one we just did?
Either way.
Either way is fine.
Okay. So myself, I was selecting number 1, 6, 11, 16, and 21.
Okay.
So what was yours?
I used the random generator to compare all mine, and I came up with 3, 9, 2, 14, and 23. And to compare that to 3 others, I generated 3 more. But so
when I cut them out, oh, good.
Okay.
So I cut them out, and I got 1, 13, 14, 21, and 28 when I drew them randomly.
Okay. So then the mean for the random numbers that I just chose was 45,300.
5,300?
Yes.
Kevin, what was yours?
Mine was 48,720.
And mine was 45,240.
Okay. So then it says, this graph illustrates the distribution of sample means. There are 142,506 possible combinations of the 30 salaries, around 5 at a time. This graph represents the distribution of all possible samples. Make a mark on the horizontal axis and indicate the value of your sample mean from part A. So mine was almost in the center of the graph.
As was mine. Mine was very close.
Mine wasn't too far. It was a little on the high side, but I wouldn't say it was way out there.
Yeah, because you said it's 48,700. That's kind of close there. Because mine was close to the middle. So then for letter C, it says, does your sample mean appear to be unusual? Explain why you think it is or is not unusual. So what do you think?
So I don't think any of them are unusual. They fit right in there, and if they're very close to the mean. There's not significant deviation there that I'm aware of. It seems to fit within the pattern, and I would imagine if we played this game over and over and over again, that we would end up with being very similar.
Mhm.
I agree. Yeah.
That's correct. So yes, that I was considered mine was usual, not very unusual. Okay. So then we have for letter D, it says compare your mean from question 7, section A, to the mean obtained by at least 3 other individuals. What do you notice? In practice, you only get to see the means from the samples you draw. You do not get to observe any other mean that could have occurred. So
I think like you were saying, Sean, that that if we keep doing it over and over, we're going to find that they're all pretty usual and kind of get close to that mean.
Yes. Yes, because if we choose those randomly, we are not going to get just only the higher salaries, because that will make to be unusual or very low salaries. Yes, just choosing those randomly will make us to be kind of about in the center, close to the mean.
Right.
Okay.
Yes.
As it's for our 3 examples, 45, 48, and 45,000. Those are not too far from each other.
No, they're not.
Okay. And so then moving on to number 8, it says the graduate manager admission test is used as an admission criterion in many masters of business administration programs. The scores on the GMAT are normally distributed with a mean of 529 and a standard deviation of 113. Consider a simple random sample for n equal to 10 students taking the GMAT. It says for letter A, what is the shape of the distribution of the sample means for all such samples?
Well, if I had just read that question without doing the reading in the book, I would have been completely lost and not had a clue.
Yeah.
Yes.
The reading in the book made it pretty obvious that, if it tells you in the question itself that it's normally distributed, the parent population.
Exactly.
It's giving you the hint in there.
That's what I went with, so that it would be normally distributed because the parent population was normally distributed.
That is correct. And
Right.
actually, that's the answer for the next question.
Yep.
Because it says, how do you know that the distribution of the sample mean has the shape? It's because the parent population is normally distributed.
And so if it wasn't normally distributed, but the sample size had been 30 or greater, then that would be the other law, correct?
Yes.
Exactly.
It says for the course, if it is 30 or greater, it will be approximately distributed.
Right.
Right. And it said that that's not necessary. Like 30 is not a definite number, but I think for this class, it says that that's what it would be used for.
Right.
Yeah, it's only for the course. Okay. So then letter C says, what is the mean of the sample and distribution of sample mean scores for all such samples?
$529.
Correct.
Yep. That's what I got.
And then it says, what is the standard deviation of the distribution of sample mean scores for all such samples? I got 35.734.
Yep. That's what I figured too.
Now I got that, but it's taken me a bit to get my brain wrapped around why we get there. But I guess the why, as long as I can remember the formula, I'll be fine.
Yeah.
Yes. That is because
I know, I was trying to figure out the why too.
It is the standard deviation divided by the square root of n. The square root of n.
Yeah.
So we had 113 divided by square root of 10.
Yeah.
Okay. So I think, do you have any question in regards to this section of the material?
I don't think I did.
No. I just went into the material and this for Mass Clear. What about you, Sean?
No, I don't have any more questions on that. Like I said, the formula, it makes sense that whenever you're using the standard deviation in the square root of the sample size, the larger that sample size, then the smaller your fraction's going to get. That makes sense. It's just a matter of remembering what the the formula is.
Yes.
Yeah.
Okay. So then, are you ready for the quiz then?
Sure.
Let's do it.
Go ahead and pull that out.
Quiz.
I apologize. I've been sneaking little bits of popcorn here. I didn't really have a chance for lunch today, and
That's fine.
That's all right.
That happens quite often.
yes.
It says just instructions. Do not round until your calculation is complete. Okay. So do you have it pulled up now?
I have it, yes.
I'm ready to go.
Okay. So then it says question number 3. When you are taking a sample size of n equal 5, what is the shape of the distribution of means? Histogram when the parent population is right skewed.
So
When the parent population is right skewed. Then what do you think? But this one,
Let's see. Because I just went to like the sampling distribution and did a right skewed one, and with the n equals 5, and it's pretty normal. I mean, slightly skewed. I mean, it's slightly skewed, right? But I don't know if that would be enough to mark that.
yeah, it's n equal 5.
Because I mean, it doesn't match either of the two for a normal, because the parent population is skewed, so that's not normal. And the sample size is small.
Yes, it's just 5.
isn't it slightly skewed right, but it's still fairly normal?
Yeah.
That's what I could say.
I mean,
Because he has just entering the n by 5.
Yeah, so I'm not sure what.
okay.
I mean, I'd say it's more normal than skewed.
Mm-hmm.
I don't know what you guys think.
Yes, because it's not too much, it's just a little. I would say it's normal, because it's not very, very right skewed.
Mm-hmm. I mean, the only thing that makes me think otherwise is that neither of those two criteria match for the, the parent population not being normal and the sample size not being large. But I mean,
Right.
looking at it, it looks, I would say, more normal.
I mean, whenever you look at your mean versus your mean is still, I mean, if you do 10,000 reps, the mean is still, it's slightly skewed, but it's not drastic.
Mm-hmm.
So it is skewed to the right, but it's not. I vote for skewed right.
Okay. I think I'd agree with that.
Okay. So then question number 4. It says when you are taking a sample size of n equal 100, what is the shape of the distribution of means histogram when the parent population is right skewed?
Well, that would be normal because the population size is, or the sample size is large.
Right.
Mm-hmm.
It comes back to that. It's about normal,
Mm-hmm.
but there's not enough of a difference in this one versus the other one. I mean, you still have it's a median of 8.0 and a mean of 8.08. So it's skews at 0.15. So it's about normal, but it's still slightly skewed to the right. So was I wrong in my other?
Right.
Yes, that's about.
Yeah.
Yeah, it does make a difference. Okay.
Okay. Just give.
Oh,
So are we going with normal on question 4 then?
I think it's normal because it does match the definition or the criteria of being a large sample size.
Okay.
Question 5, when you are taking a sample size of n equals 5, what is the shape of the distribution of means histogram when the parent population is normally distributed? So that one should also be normal, as the parent population is.
Right. I agree. Did we lose Kevin?
I think so. Looks like he's trying to get back on. Was Kevin's audio kind of in and out before? Or was
Yeah,
it just
you're
my computer?
breaking up. There you are, Kevin. You're moving. You're just a little choppy.
Yes, I think it's the connection. It's kind of slow. Now, can you hear me now?
Yes.
Yeah, it sounds a lot better
Okay,
now.
Okay, thank you. Okay, now number. Okay, so who wants to read the next one?
Did you get 5? We did 5. I don't know if you were.
No,
Trying to get
I
back
just
on or
lost
not.
number 5.
Okay. So
Okay.
number 5 was normal because the parent population was
Mhm.
normally distributed.
Yes, that's what I thought. Okay.
All right, so
So
I'll do 6.
Go ahead.
When you are taking a sample size of n equals 100, what is the shape of the distribution of means histogram when the parent population is normally distributed? So again, that would be normal.
Yes.
Right. Question 7. When would the distribution of means be normally distributed? Choose all correct responses. Data drawn from a population that is normally distributed and the sample size is small would apply. Data drawn from a population normally distributed and the sample size is large, that would apply. Data drawn from population that is right skewed, sample size is small, would not apply. Data drawn from population that is right skewed and the sample size is large should apply.
Yep.
Yes.
Sounds good.
Mm-hmm. Okay, question number 8, it says, which of the following gives the best explanation of the central limit theorem? If the parent population from which the data are drawn is normally distributed, then the sample mean will follow a normal distribution. The second one, of course, it's not that one. It says for bell-shaped data, approximately 68% of the data will be within 1 standard deviation of the mean. That's not that one. And then the third one says if the sample size is large, the sample mean will be close to the population mean. And then fourth one, it says if the sample size is large, the sample after distribution of sample means will be approximately normal. So with this one will be the first one. So it says if the parent population from which the data are drawn is normally distributed, then the sample mean will follow a normal distribution.
Is it not the last one? I was thinking it was if the
That's
sample size is large, the shape of the distribution of sample means will be approximately normal. That's what I thought it was.
that's what I got from the reading, was that if it's, I mean, in my notes, I wrote down right under central limit theorem, the
Mhm.
sampling distribution of the sample mean will be approximately normal if the sampling size is sufficiently large.
Okay.
Uh,
Do you want to go with the last one?
so yeah, I think it is that one.
Okay.
So we're going to use
And
the
that
following information.
first
Oh, go
one-
ahead.
The first one there, that was just one of the when X is normal, it was just one of the rules that said was always true.
Mm-hmm.
Right. Yes.
Okay.
Yeah.
Okay.
Yeah. And I think that third one, that's the law of the large numbers. Is that what it's called?
Mm-hmm. Yes, the third one, and yes.
Yeah.
Okay, so
Okay.
use the following information to answer the next 4 questions.
I have the random variable population mean of 10, standard deviation of 6, and sample size of 36. And then first it's asking for the mean of the distribution of sample means. So that one will be 10.
Correct?
Right. Yeah.
So
And
the
this-
deviation, that's going to be where you do
The
6.
formula.
Yep. So that's standard deviation, which is 6, divide by the square root of 36,
Mm-hmm.
which is 1. If without if my brain works.
Yes, it will
That's
be
what I
1.
came up with. It is 1. Okay. All right. So regardless of the distribution of the population, if the sample size is large, greater than 30, what would the shape of the distribution of the sample mean? So that would be normal if it's large.
Mm-hmm. So then it says question number 12, what theorem would justify a response to the last question?
Law of large numbers.
Mm-hmm. Okay.
Yep.
So let's go ahead and submit it then.
Okay.
Oh. Tells us we missed one.
That
Says we-
last one, the central
The
limit.
last one. The central limit theorem.
I guess. Aha. Go back and read your notes. It's in there.
What'd you find?
Just exactly what we discussed earlier in the
That's a
conversation.
30.
The definition of the central limit theorem says that the sampling distribution of the sample mean will be approximately normal if the sample
that is-
size is sufficiently large.
Yes, have it in my notes as well. But I thought it was, well,
Well,
Yeah. Okay, that makes sense.
I guess go back and resubmit, but
Can you go back and redo it?
you're allowed to do it
we have,
twice.
I think, 2 attempts.
Oh, we have 2 attempts?
Mm-hmm.
Okay.
Yeah.
So let's go ahead and open it up again. Okay, it's true. True.
This question should all be the same, right?
Yes, the same question, same order as well.
Mm-hmm.
All right, gonna resubmit it.
So yes, it is a central limit theorem.
All right, perfect. Good deal.
So then I think we're all set for tonight.
I believe so.
Yep.
So then on Thursday at the same time.
Sounds good.
Same time, same place. I'll see you here.
Okay.
All right,
So
thanks,
then see you
guys.
on Thursday.
Thank
I will
you.
submit the link. Have a good one.
All right. Good night.
See you
Goodbye.